Hello, today we are looking at the properties of algebra. Let's start off looking at the commutative property. And the commutative property is basically saying order does not matter in some cases here. First of all, for addition, we all know that 3 plus 7 is equal to 10, and we also know that 7 plus 3 is also equal to 10. So since both of these are equal to the same thing, we could say that 3 plus 7 is equal to 7 plus 3. In other words, your order does not make a difference. You can have the 3 first or you can have the 7 first. Both will add up to the same thing. Similarly, you can do the same thing for multiplication, where 3 times 7 is going to be 21. 7 times 3 also is equal to 21. So 3 times 7 then must equal 7 times 3. And again, order does not make a difference. The associative property is saying something also similar, but it's kind of talking about lumping some things together here first. So let's say in this case we're going to need a third. So let's do 3 plus 7. We're going to do those first. Plus 4 is equal to, well, we already know that the first part is 10. Add in the 4, that's 14. Let's do 3 plus 7 plus 4. And order of operations says that I would do the 7 plus 4 first, which would give me 11. So now I've really got 3 plus 11. That's also 14. So again, we see that where we put the parentheses in this case, because it's just addition, we're not changing any operations here. We're working all exclusively with addition, that these will equal each other. And multiplication is the same thing. If we had 3 times 7, all of that times 4, well, 3 times 7 we said was 21. 21 times 4 is going to give you 84. Compare that to 3 times 7 times 4. 7 times 4 is 28, and if you do 3 times 28, well, again, you've got 84. So the quantity 3 times 7 times 4 is equal to 3 times the quantity 7 times 4. The parentheses are not really making a difference there. We're just doing multiplication. So we're still following order of operations there. The identity property of addition is basically telling us that if you have some number, 3, and then you add 0 to it, it will still be that number, any number. So in this case we could say a, where a is standing in for some number, plus 0 is still going to be a. That's the identity. It is itself. For multiplication, we are not going to use 0. What do you think might have a similar property in multiplication? Well, if we had 3 times 1, that gives us 3. Similarly, a times 1 gives us a. So for addition, the 0, and for multiplication, the 1, have unique properties that allow us to add in the case of 0 and multiply in the case of 1, and not change the value or the identity of the number that they are operating on. The inverse is also similar to that. So if I've got, for the inverse property of addition, if I have 3 and I add negative 3, that's going to give me 0. If I have any number a, and I add negative a, that will also give me 0. And it even works, it's interesting, if we have a negative number in here. So, not to get too crazy here, but let's say for a that we want to use negative 5. Okay? So we have negative 5 plus negative 5. And negative 5 is actually the same thing as negative 1 times negative 5, which is just 5. So we'd have negative 5 plus 5, and again, hey, there we go. That is 0. And again, with the inverse for multiplication, if you have a number 3, let me draw a line here to separate these two, and I'm going to scroll down a little bit, but I want to keep inverse on the screen. If I have a number 3 and I multiply it by 1 over 3, that's going to give me, well, I would multiply it out. If I'm multiplying fractions, 3 is the same thing as 3 over 1. I would multiply straight across. 3 times 1 gives me 3 in the numerator. 1 times 3 gives me 3 in the denominator. 3 divided by 3, anything divided by itself, is just 1. So if I have any number a times 1 over a, this is equal to a over a, which is 1. This always holds true, even if I have a negative number, even if I have negative 5 times 1 over negative 5, that's going to give me negative 5 over negative 5. The negatives there will cancel one another out, and I still get 1. That works. The inverse property basically, again, gives us, for addition, it gives us an end result of a 0, because you add a number and its opposite. And for multiplication, it gives us 1, because you are multiplying a number and its, we have a word for this here. This is a word that should definitely go into your notebooks. This is a reciprocal. Okay, it is a reciprocal. It is 1 over the value of that number. 1 over a. That's your perfect reciprocal for any number a. Alright, and our last one here, distributive, and we've seen this guy before. So if I have, let's say, 5 times the quantity 2 plus 3 equals, well, if I followed the order of operations here, I should start with my parentheses. So 2 plus 3 is 5. So really this would be 5 times 5, which equals 25. Let's distribute this 5, hence the distributive property. And this is for addition here, first of all, I'll note that. If I have 5 times 2, well, that will give me 10. And then I have to multiply the 5 times the 3. Plus 5 times 3 is 15. Hey, what do you know? 10 plus 15 gives us 25. It works. So those are your properties of algebra. Review those, make sure that you feel confident with them. They are the foundation of what you will be doing for a lot of your Algebra 1 course. Thank you for your time. Have a great day.